All right, level 3 chem, let's go over the do now answers so that way you're ready to do some more practice problems. So, in this reaction, when we were looking at that question, you had aluminum, the metal. Where is it? That one. We had Al, and you added it to a solution that had copper as the ion, Cu2+. Is it upset? Why are you upset? There we go. All right. So we mix these two things together, aluminium and the copper 2 ion, and what we form then is the aluminium ion and the copper metal. Are we okay with that so far as an equation? Now this equation is unbalanced. And what I want us to do is split it apart into the two different reactions to figure out what's oxidation and what's reduction. So the way we're going to do this is taking things that are the same element down. So for example, aluminium and aluminium, let's move those down. So Al becomes Al3+, and we'll take the Cu as well, Cu2+, and Cu. So what I've done is I've taken this equation and I've broken it down into 2 halves. Halves. Are we okay with how I did that? Does that hopefully sit well with people? All right, the next thing I want to do is assign oxidation and reduction. The way I'm going to be doing that is by checking the charges on these ions and the elements, and then also seeing if its oxidation number has changed. So what I see here is I have aluminium, the metal, Al. Since this is in the elemental form, its oxidation number starts at 0. And then it's going to Al3+, we have become an ion. Since it's a monatomic ion, its oxidation number is the same as its charge. So Al3+, its oxidation number is +3. So we see an increase in the oxidation number. So we think increase, oh dear, keeps dropping out. That's not cool. There we go. So if we see an increase in oxidation number, is that oxidation or reduction? You remember from yesterday? It's oxidation, because I have lost electrons. Remember, electrons are negative. So we've lost how many electrons? 3, because that's now +3. So this is an example of loss. Remember, electrons are negatively charged, so if we're losing that negative charge, it becomes a positive. And if we think about the acronym that we talked about yesterday, Leo the lion says grr. Loss of electrons is oxidation. So this half equation is the oxidation half. Making sure it focuses. Is everyone okay with that? It keeps dropping out, doesn't it? This is what happens with technology. All right. Now, something to remember with redox is that we should always have a pair. If one's going to be oxidation, we always have a reduction as well, because we can't create or destroy matter. So I should see electrons, and I should see electrons on this side, because this guy's lost the electrons. This one will take the electrons and gain them. So let's check our oxidation numbers again. Copper 2 is Cu2+. Its oxidation number is the same as its charge, so that's +2. And then we have copper in the element form. What's the oxidation for elements? 0. So if I look to see how the oxidation number has changed, it has decreased. So that hints to me reduction because I've gained electrons. The other thing I can do is check the charges. So I see how this is a positive 2 and that's now a 0. So we have gained 2 electrons for that. So since I've gained, Leo the line says grr, this half is my reduction half. Like I said, you should always have one of each. I'm just going to keep clicking this. I see it. I might need to restart this later. Oh, come on. This is what happens when we're trying to use technology. I'm trying to be smarter. Are we happy with how I figured that out? Okay, split it up, check the charges, see how the charges are behaving. The thing that trips a lot of people up, especially the newbies, is that electrons are negatively charged. Gaining them means I am losing my charge. All right, last step that I wanted to talk about is how do we put these two equations together? So just as a reminder from that checklist, the achieve requirement is figuring out which one's oxidation and reduction. The merit requirement, or one of the merit requirements, I should say, is doing the half equations, which is these guys over here. And then getting towards the excellence requirement is putting these two half equations together. The way I do that is I check to see how many electrons do I have on each equation. So in the oxidation, I have 3. In the reduction, I have 2. I can't put them together right now because these electron numbers do not match, so I need to find the smallest common number that they share. The smallest common number that they will share is 6. So I multiply the top half by 2, so that way these electrons now become 6. So if I multiplied this 1 by 2, that's 2, 1 by 2, 2. Are we okay with that jump? All right, bottom equation here, I want to get this 2 to become a 6, so I'm multiplying the whole thing by 3. So that becomes 3. So that becomes 6, that becomes 3, that becomes 3. Now I just need to put them together. So when I put them together, these electrons will cancel out. That's the whole point of what I was doing. Sorry, see it? Fixing it. Fixing it. There we go. So these 2 are 6, so that's going to cancel out, which is what I want. Let's put them together. Let's grab another color. So these 6 cancel out with these 6, and then everything else just gets pulled down. So that's 2Al plus 3Cu2 plus makes 2Al 3 plus 3Cu. And that's my final balanced equation. And that's working towards the excellence level now. All right, questions, concerns, comments? No? All right. Plan for today then is to give you guys some practice questions like this, just to make sure we're feeling confident about this. And then afterwards to play the GIM kit again, just to reinforce it. Don't give me that face. Okay. I need to make sure that we are really confident with the vocabulary before we move on to looking at the level 3 material, because otherwise I'm going to be talking and you're not going to understand what's going on. So I want you guys to be confident with this. This classification as well between the oxidation and reduction is an achieve requirement, and it's the first step. If you misclassify it, doesn't matter how beautiful your answer is, it all gets marked wrong. So we need to make sure we get this right. All right, cool. So I'll put back on the screen, explain what we're doing. So I have given you guys 8 problems to do as practice. They are just like the do now. They are unbalanced. I want you to do the exact same thing. Split them in half, figure out the oxidation and reduction halves, and then balance them. Just be mindful that I couldn't do subscripts or superscripts. So the numbers behind like this, that should be a 2. That's small. And then these guys up here should be charges as well. I'm happy to write them on the board so you can see the subscript, superscript. Do you want me to do that? Okay, I'll do that. Cool. All right. I'm going to do another example for you guys just because I noticed that you're getting on to question 3 and you're struggling because it's an unbalanced one and it's quite an annoying one. For question 3, what we're looking at, aluminum fluoride. All right. Some of you guys have been having a hard time with this and totally understandable. All right. So let me think about what's the best way to explain this to you guys. Let's break this up first off. Did I write that correctly on the board? F2? Let me just see. Or did I muck up? No, I didn't. Okay. All right. Let me show you guys how to do this one because I noticed some of you guys were struggling with it. Break it apart into its 2 half reactions. So just as a reminder, when I break up aluminum fluoride, aluminum is Al3+, and then the fluoride is F-. Are we okay with that? Are we okay with that so far, with how I broke that apart? All right. Keep in mind when we're talking about ionic formulas that we want to have multiple of the fluorides because we want it to add up to 0. So since this is a positive 3 and this is only a negative 1, I need 3 more fluorides for that to add up to 0. So when I check the charges, the aluminum is a positive 3 and the fluoride is negative 1 times 3. If I have negative 1 times 3, I get negative 3. And if I add those 2 numbers together, I get 0, which is what I want for an ionic compound. So that's why that ratio is the way it is. Are we okay with that? Am I reasoning with that? All right. Let's break this up. So first one here is I have Al3+ becoming Al. And the second one, which is kind of nasty, and I'll walk you guys through it as the example, is there'll be 3 fluorides, and it gets to F2. Are we okay with that? All right, I'll do the first one because that one's easier. All right, so when I'm looking at this, you see how it's a positive 3, and that is now 0. So if I'm decreasing my charge and I'm decreasing my oxidation number, I'm going to be gaining electrons, right? When we're showing gaining, we show them before the arrow on the reactant side because they're being added to the aluminum. All right, again, Leo the Lion says grr. It's okay if you need to write that on your paper to remember. Gain of electrons is reduction. So we see that this is on the reactant side, aka before the little arrow thing. So I must have gained it. And if I gain electrons, that is my reduction half. Happy campers? All right. This second one's a little bit more complicated, so let me walk you through it. Now, first thing I want to do is I want to make sure, we didn't have this problem before, is I want to make sure that these 2 numbers are the same because I can't create or destroy matter. In this case, it was 1 and 1, so nothing needed to change. In this case, I have 3 and 2. So I need to find a common denominator, a common number that they both share. So the closest number I have is 6. So I could do 2 times 3, and that becomes 6. And then this number here in front can change to a 6. Are we okay with that? All right, on this side here, we have a -6 charge because I have 6 fluorines. On this side, I have no charge. So I need to make these two numbers match. So I need to add my electrons. Electrons are negative, so I'm going to add them onto this side. So that way it brings the charge down to -6 as well. So how many electrons do I need to add? 6 electrons to that side too. So you see how this charge is -6 and this charge is now -6. They balance. It's like a teeter-totter. All right. We see that the electrons here are on the product side, which is after the arrow. So that means that these electrons have been released from the fluoride. And if we lost electrons, go back to Leo, the line says grr, that tells me this is my oxidation reaction. You should always have one of each, because these electrons here are going to go here. We cannot create or destroy matter. It's a fundamental law. All right, next thing we do is we check our electron numbers, see if they match. This is a 6, this is a 3. So I need to multiply this equation by what number? 2. So that becomes 6, that becomes 2, that becomes 2, and now I can put everybody together. So the 6 and the 6 cancel out, and then I can write what I have left over. 2Al 3 plus 6F minus becomes 2Al plus 3F2. Okay? Okay. You guys ready to keep practicing? Okay. We have about 15 minutes left. How confident are you guys feeling? If we could see, okay. Nice and clear, hands up. Thumbs up if you feel confident, thumbs down if you don't. Thumbs like here if you're kind of like, just want to see where everyone's at. Most of you guys are kind of like semi-okay. And there's lots of stuff. Do you guys feel like you need another lesson just to digest this?
Yes. 100%.
Yes, most of you guys are yes, and you guys are no? All right. Cool. Just wondering, just want to double check before I move us on. I'll put those questions, those questions are on the board, so we'll keep practicing them. We might do a little bit more practice with this next session, depending on what we get through in those 15 minutes, okay?